Okay. Hello, everyone. Nice to meet you here in Sydney. Okay. Hey. Yeah, it works. So my name is Andrei. I'm a software developer using Ruby for almost 15 years now. And also all technologies around. I'm a fan of Postgres. I can deploy apps to Kubernetes, but I don't like it much, and do other scary things. Initially, I'm from Russia, but recently in 2022, I moved to Japan, partly because of reasons. The horrible things Russian authorities do with impunity, and partly because I like Japan so much. I'm happily residing in Japan since then with my family, enjoying Japanese order and safety, and calm road traffic while riding on a moped around my neighborhood. So if you are thinking about moving to Japan, let's chat about it. After the talk, I have got some experience to share. And I'm very happy to finally get to Australia. When I saw RubyConf Australia call for speakers, I looked at this Mercator distorted map and thought, wow, Japan and Australia seems to be not so far from each other. Well, relatively, yes, they are. But Pacific Ocean is so huge, and Australia itself is so massive. Like, I was surprised. It's almost 8,000 kilometers from Sydney to Osaka. This kind of worldview distortion caused by the fact that we are so used to maps based on Mercator projection, which makes everything that is closer to Earth poles to seem much bigger than it is. It's bugging me a lot. And we will talk about it a bit later. I have to confess, actually, I'm an alien, an evil Martian agent undercover here on Earth. Came here to own Australia. Evil Martians is a distributed web development agency helping companies all sizes, from small startups to big enterprises, to live and prosper. We help them grow, startups to grow effectively, enterprises to speed up their huge monolith and test hypotheses. And also we are focusing on developer tools recently, open source, and effective software development practices. Australia still is a terra incognita for us, and we are looking forward to help Australian companies to build better software. So if you need help with performance, scaling, architecture, implementing best practices, or just need to strengthen your team with experienced engineers, feel free to reach to us. We now have a few engineers in Japan, including me, in almost the same time zone as you, which can be very helpful. And one thing that we truly love is open source. We love to use it, and we also love to give back enhancement to the community. We're eager to share results of our work as a Ruby gem or NPM package. It will help us in the first place to reuse our own solutions, and we can help others, you, to solve your problems. And often we will get feedback or patches back, so it's a win-win situation. And like Tesh mentioned it in the previous talk, it will help us to get recognition between you. It actually helps us to hire people, so it's a good thing to do, like from any point of view. For many years, we have created literally over 100 of open source products, big and small, famous and not so. Very probably your application already depends on a few Martian gems. So check your gem file and count how many our gems you are using already. For example, I created that small Yabida mini framework for instrumenting Ruby applications for easier monitoring and observability. And some of our open source products have even grown into commercial projects like AnyCable or Image Proxy. Like still staying open source, like that open core model. So we are even starting to earn money from our open source. Like I'm very proud of it. But let's get back to worldview distortions. And now let's take a look at how we, programmers, can sometimes undervalue even most basic language constructs just because we are so used to them. Let's talk about callbacks in Ruby. What callbacks? No, not this, not this. I know many people have had bad experience with them, me included. I myself sent emails from Ruby Rails models. Don't do that, please. I beg you. Use active record callbacks only for keeping data consistent, nothing else. Let's talk about Ruby blocks. I believe that it's so idiomatic and so common to use, for example, times method on integers in case if something needed to be repeated several times, that no one really realizes that while it does the job, it technically is very different from for loop in Ruby or other languages as well. Block in Ruby is not just a sequence of instructions between do and end, but internally is much more similar to functions or methods. First you declare a block, and then it got called by times method several times, passing counter as an argument. And internally, executing a block is very much the same as calling method. CRuby needs to create a special C data structure, push it to the stack, along with parameters, if any, move code sequence pointer there, and etc., etc., so a lot. I won't deep dive into internals today. Instead, I would recommend you to read an awesome book called Ruby Under a Microscope. It's really enlightening reading, especially if you are familiar with how computers work on low level. All those extra steps to execute the block, of course, make it a bit slower than just a for loop, but in real-world applications, where you have to do some real work, something more than just incrementing a counter, this difference becomes negligible. Don't sacrifice readability by looking on micro benchmark results as this one. And it's also not the point of this talk either. The point is that in Ruby, blocks are used as callbacks. If, for example, in JavaScript or Golang, you would pass a function as an argument value to another function to be called back, Ruby has a special entity with and special syntax for declaring callbacks. And this is great. Ruby has callbacks as a first-class citizens, unlike many other languages. What is important to know, though, is that block is more than just a kind of function, it's also a closure. Every Ruby block can be represented as consisting of two parts, the code to execute and the environment where this code should be executed. First part is simple. You pass instructions between do and end, and they become the block body. Environment is a bit more tricky. Block remembers all local variables that were defined before its definition. Also, it remembers object in that scope it was created, the self object. And when you call a block, it executes in this context, magically referencing variables defined very far away and maybe very far ago from the place it was defined or executed. But this environment is not immutable. It can be changed. Moreover, there are more things that can be included into the term environment, and this is the thing I want to focus on today. Most frequently changed thing in the environment is the binding, the self object. Usually, this change is done on purpose to allow building nice domain-specific languages, DSLs. However, if you don't aware about that happening, that method that receives your block will use instance exec, you will be surprised by cryptic error messages about undefined methods. For example, let's take a look at a method that receives a block and executes it, but changes context of this method's object using instance exec. If the code using this API will try to define a block that uses self of the block creation place, block creation class, it will fail with mysterious error message complaining that it can't find the code that obviously is right here. Like here's conf, and here we are referencing conf, but wow, when block is executed, there's another self. This can blow your mind, so be prepared. Okay, you can think that as block is a closure, you can save current self into a local variable and reference it later. It will work, but it's not reliable either. Say you have a block that uses a local variable, and then you reassign this variable and you call the block again, but you will see that block that was defined earlier will use the new value of the variable, not the one it was created with. This behavior is truly mind-blowing, but still perfectly valid. The reason for it is to allow multiple blocks to share access to common variables, like working with a counter, like in this example from the same Ruby under a microscope book. Okay, let's explore other things that we can include into the term environment. One example of this is the current thread that is executing the block. Fun fact that thread creation itself uses blocks to define a body of the new thread, but it's again not in the scope of my talk. Anyway, you can call a block from different threads, even from multiple threads at the same time, and enclosed variables will be accessible. And it's fine, as long as you don't try to mutate these shared objects, like in this example, as heavy dragons. The real problems will arise if you will try to rely on a thread local data from a block that can be executed from different threads. To be specific, if you try to use thread.current with the same key from one block or from the other. Because sometimes there will be no guarantee that the same thread will be used to execute the same block, especially if you use higher level concurrency primitives like thread pools or promises from the concurrent Ruby gem. Or most probably, if some library that you are using uses these primitives internally under the hood, and you don't aware of that. And this is not a theoretical problem. Like, for example, let's take a look at Nuts client for Ruby, Nuts pure gem. It uses blocks as a callbacks to process incoming messages from subscriptions. Okay, what is Nuts? Who knows? Who uses Nuts? Oh, no one? Okay, Nuts is a performant and simple to set up message broker written in Golang. It's very fast, very simple to set up. Anyone who tried to deploy Kafka to Kubernetes will understand the pain. And have many features aside of PubSub, like persistent message queues, etc., for example. So Nuts is nice. Like, I like it very much. So try it for your maybe next project. But here's the story. Like, before version 2.3, Nuts Ruby client was creating a separate thread for every subscription, and for every new message for the same subscription, callback was executed in the same dedicated thread. And if you would try to use thread.current in the callback, it would work then, but then I came there and changed implementation to use a thread pool, and now every callback is executed in some thread. And you can't rely on thread.current anymore. Why I did that? Because of performance, of course. As you should know, context switching is a very expensive operation, and creating a new thread for every subscription to handle occasionally received messages is a pure waste of resources. Moreover, there is a limit on number of threads in C-Ruby, at least, that can be created in a single process. And if you have a lot of subscriptions, tens of thousands, you will hit it. On my machine, on this laptop, Ruby crashed after around 32,000 subscriptions and threads, respectively, were created. But with fixed side thread pool, you can control the number of threads and reuse them, and avoid context switching overhead. My benchmarks showed that for tens of thousands of subscriptions, thread pool is several times faster than individual threads, solely by reducing that context switching overhead. But after this change got merged, I started to think about whether the behavior of the NAS client changed or not. And I realized that it did. And frankly speaking, it could be a breaking change, but only if this behavior was specified somewhere. But it was not specified. There was no promise that the subscription callback will be executed in the same thread every time, so it can be treated as a mere internal implementation detail. No need to bump major version, yay! Hopefully no one used thread.current in the NAS callbacks. It seemed to be not that common technique anyway. Hopefully no one created issue. But what is important to understand, in my opinion, is that in real-world application, your code is working inside of some thread pool mostly always. Will it be Puma application server or Sidekick worker? So don't use thread.current in your application anyway. Use current attributes in Rails instead, for example. But the most disappointing thing here is there is no easy way to understand whether your block that you defined will be executed within instance exec or in a separate thread, or will it be executed at all, and when? The only way is to read and grok the source code of every library you are using, which is a good practice anyway, but pretty hard to do. Well, that's the end of this little journey. Hope that you enjoyed this little tour into the Ruby blocks. And may the new knowledge help you to avoid some subtle bugs in your applications. Amen. That's it. Please check out our Evil Martians blog called Martian Chronicles. We have a lot of interesting articles about Ruby, Rails, front-end design, and other things. Also, I have Martian stickers like this one, so if anyone interested, please come to me after the talk and grab one. And let's chat about everything, be it Ruby or Japan or motorcycles or anything. Don't hesitate to reach me in social media and ask questions even after the conference. And if you, by any chance, will go to Japan, to Osaka, also let me know and we will meet. Thank you a lot for your attention. Thanks to Ruby Australia for organizing that amazing event, choosing my talk, and giving me a chance to speak here. And let the lunch begin.